I'm DevBoodle. Today I'll be showing you how to procedurally generate terrain in Godot. More specifically, we're going to generate a height map that is randomly offset by some noise. So the first thing we want to do is create a new node. This is just like a basic environment I have set up here, so you don't have to have any of this. So let's create a new node. It's going to be a mesh instance 3D. Let's rename it to terrain. And then let's give it a new script. All right, the very first thing I'm going to do is make it a tool script. This will be useful so we can debug stuff in the editor and see what it looks like without having to load up the game each time. Okay, so there's a couple variables we want to set up immediately. First of all is going to be size. This is going to be the width and length of the terrain. So I'm just going to say it's going to be 256 by 256. And then we're going to also export a variable called resolution. So I'm going to have this range from 4 to 256 and step by 4, call it resolution. And by default, I think we're going to have it at around 32. Then what we're going to do is we're going to add in a set function for this. What this variable is going to do is it's essentially going to tell it like how detailed the terrain should be. So should it be more blocky or should it be like more defined? So let's set the new resolution. And then we're going to call a function called update mesh. We haven't declared this yet, but we will very soon. So let's define it now, actually. Function update mesh. It's not going to take in any parameters, and it's not going to return anything either. The first thing it's going to do is create a plain mesh. So we'll just do plain mesh.new. Then we'll set its amount of subdivisions. This basically defines how like high res the plane is. So subdivide depth we'll set to the resolution, and then we'll do the same thing for subdivide width. Then finally, we'll just set the size of the plane, which is just going to be a vector 2 with the size constant as both of its components. Now, the plane has a very handy function called getMeshArrays, which we are going to use. So plane arrays equals plane.getMeshArrays. This essentially gives us the arrays containing its vertices, its normals, basically everything we need in order to create our own mesh that starts out as a plane. Finally, we'll create a new array mesh, which is just going to be arrayMesh.new. We'll do array mesh, add surface from arrays. It's going to use triangles, and then we're going to pass in the plane arrays. Now, if we set the mesh of this meshed instance equal to the array mesh we just created. Okay, now what I'm going to do is close the scene and reopen it up. Now if we go to 3D here and change resolution, as you can see, we get the plane. So at the moment it has a resolution of 40. If we go into wireframe mode, you can see that means it's divided into these 40 sub squares. And as we change resolution, it gets more and less detailed. So we can set it's like 4, for instance, and now it's way less detailed, but we can set it all the way up to like 256, and now it's super detailed. Like, we have to zoom in quite a bit before we can actually begin seeing the triangles. So let's just leave it at the default 32 for now. We can change it later once we actually know what it's going to look like. So let's go back to script, and now that we have this basic plane mesh working, now what we need to do is offset the vertices. So I'm going to offset each vertex by some amount of noise. So essentially it's going to be randomly generated. Let's add a new export that we'll call noise. This is going to be a fast noise light, and we'll also add a setter for this. Noise equals new noise, and then we update mesh. And then what we're also going to do is do if noise noise.changed.connect update mesh. Essentially what this is going to do is if noise exists, then we want to make sure that anytime any of its like variables gets changed, we want it to update the mesh automatically. So we're just adding this here. It'll just make things more like consistent. Okay, now we're going to add in our final export variable, which is going to be called height. So I'm going to have this range from 4 to 128. Let's do step by 4. It's going to be called height. And I think by default, we'll have it at around 64. Then we will add a setter for this as well. So new height. Height equals new height, update mesh again. All right, so now that we have noise and height, we want a function that gives us noise at some x or y coordinate. So basically we'll loop over all the vertices and depending on their x and y value, we'll get some new random value for noise. So let's create a getHeight function that takes in coordinates x and y and returns a height in the form of a float. What it's going to do is return noise.getNoise2d x, y, and then we're just going to multiply by height. So now we should just be able to call this function for any vertex on the plane and get some new height to set it at. What we're also going to do is create a getNormal function. So for lighting reasons, we need to be able to get the normal at each point on the plane. It's kind of a complicated thing to get, which is why we're going to create a function for it. So normals come in the form of vector 3s. So this is going to return a vector 3. So first of all, we're going to create a variable called epsilon. This is going to be size over resolution. This essentially is the distance between adjacent vertices in the plane. Then we're going to create the normal. It's going to be a vector 3. The first component is going to be getHeight, x plus epsilon, y. So you can essentially think about this as getting the height of the vertex to the right of the current one, minus getHeight, x minus epsilon, y. And this is essentially the vertex to the left of the current one. And then we're going to divide all this by 2 times epsilon. So you can kind of think about this as getting sort of an average, like, not an average, but it gives us like a perpendicular direction horizontally. Then the second component is just going to be 1. And the third component is going to be almost the exact same thing. So let's copy and paste it. Except instead of getting the left and right endpoints, we're going to get the, I guess you'd call them like forward and back. So we're going to Control X this and change it to the y coordinate instead, and then do the exact same thing here. To finish off this function, let's return normal.normalized. All right, now these functions are basically the basis for everything we're going to do. Now all we have to do is just loop over the vertices in the plane and set them. So plane arrays is actually an array containing a bunch of subarrays. So we're going to want access to some of those. So let's store them in new variables. Vertex array is going to be plane arrays array mesh dot array vertex. Now we actually have to specify the type here. So this is going to be a packed vector 3 array. Then let's just copy and paste this. We're going to do the exact same thing for normal arrays. So normal array, and instead of array vertex, it's going to be array normal. And then as well as normal, there's something very closely related to normals called the tangent, which is something we're also going to want to set. Tangent is essentially just a vector perpendicular to the normal. It's used, again, for like lighting stuff. So we'll call this array tangents. But instead of packed vector 3 array, this is going to be a packed float 32 array. Okay, now what we need to do is loop over every vertex in the array. So let's do for I int in vertex array.size. We'll get the vertex and the normal and tangent in each of these arrays. So vertex equals vertex array I. Normal we'll set to vector3.up. The current normals stored in here are not the ones we want, so we're not going to be using them at all. Same thing with tangent. We'll just set to vector3.right. Then what we're going to do is we're going to test if noise exists, because obviously, if it doesn't, then we kind of want to skip this whole part. We'll set vertex.y equal to getHeight, vertex.x, vertex.z. Because in Godot, x and z are the horizontal components, and y is the vertical. Then normal is going to be getNormal, and then the same arguments, vertex.x, vertex.z. And then finally, tangent is just going to be normal cross up. So this will just give us something perpendicular to normal. Finally, we'll update all of these in the corresponding arrays. So we'll do vertex array I equals vertex, normal array I equals normal. And the tangent array is a little weird. It's split up into multiple components. So we'll have to do tangent array 4 times I equals tangent.x. Then copy and paste this twice. And then do +1 equals tangent.y, and +2 equals tangent.z. I'm not entirely sure why tangent is formatted like this, but it should be fine. All right, with all this working, we should reload the script, soft reload tool script, re-click on this. Now you can see we have all this new stuff. So let's reset height. Let's add in a noise, so new fast noise light. And as you can see, it's already working. If we turn off wireframe, we have terrain. Now, as you can see, it's pretty bumpy. So one thing we can do to make it a little bit less bumpy is just to increase its resolution. So we could increase it to like 64 by 64, for example. Now it's slightly better. The main thing is we need to give it a proper material, because this material just isn't that good. So let's give it a new material then. I'm going to create a custom shader material for this. So let's create a new material override. It's going to be a shader material. I'm going to create a new shader that I'll call terrain. Looks correct. So we don't want vertex. There's a couple uniforms we need to add immediately. So first of all is height. What we're going to want to do is blend different colors at different heights. So for example, you could have like snowy peaks or grassy valleys or stuff like that. So having the height of the plane is going to be important. We're also going to have two textures, otherwise known as sampler 2Ds. The first one is going to be the color gradient we're going to use as it changes height. And the second one is going to be a normal map, which will help smooth out a lot of these weird shadows and stuff like that. Okay, let's make it extend all of the screen. So let's get rid of this and just work in the fragment function. So the first thing we need to do is get the position of the pixel in world coordinates. So I'll call this world vertex. It's going to be the inverse view matrix times vec4 vertex 1. If you know how the rendering pipeline works, then this should make sense to you. If it doesn't, then don't worry. It's not particularly important. Then we will get the vertex in model space. So let's call it model vertex. And this is going to be the inverse of the model matrix times the world vertex, and then dot xyz. Then finally, we're going to use this in height in order to get where we want to sample the color gradient at. So let's do float, we'll call it gradient UV. It's going to be the y coordinate of the model vertex over height, and then plus 0.5. And then I need to add a semicolon here. So finally, we're just going to sample both of the textures we have here and set them to the corresponding values. So let's do albedo equals texture color gradient, then the gradient UV as a vec2, then dot RGB. And then the normal map is going to be the normal map texture, just using the regular UV, and then dot XYZ. Okay, now this is the completed shader. As you can see, it's fairly simple. So let's take another look at this. So what we need to do is go to the terrain material now, and we need to set some of these parameters. So color map, I'll create a new gradient texture 1D. Now as you can see, we're already starting to sort of see the effect. Let's maybe slightly increase the resolution. And now we can, change this and make it different colors. Like we might want to make this bottom blue, so it's kind of like the ocean. And then, we could have this be green or something like that. Obviously, you could spend a lot of time refining what specific colors you're using and stuff like that. I just don't want to spend too much time on that right now. In the thumbnail, I'll probably have like a version where I spent a lot of time working on the colors and stuff like that. But for now, you can kind of get the basic idea of how you could have like transitions between different colors at different elevations, but not really going to worry about that right now. Now you might notice some weird artifacts at the top here because our gradient doesn't have that. That's because height isn't actually height. It should be 2 times whatever the height of the terrain is. So what we're going to do is actually go into the script and change the height uniform depending on whatever height we set it to. So let's go into here, do material override dot set shader parameter, height, and then it's going to be height times 2. Okay, so now if we go into here and change height, now you can see it's more accurately reflecting the gradient we put there before. Now the final thing we might want to set is normal map. I'm going to create a noise texture 2D And then I'm going to copy and paste this noise. So let's just copy this and paste it here as the noise. And then I'm going to click as normal map and seamless. Okay, as you can see, this is like smoothed out a lot of the bumps by creating more finely detailed stuff. We might actually want to increase the resolution of this a little bit. So let's do 1024 by 1024. And obviously you can edit the specific normals or the specific noise texture and stuff like that to get different looking stuff. You might even want to blend different normal textures together with elevation, like we did using the color gradient. But this is the finished effect. This is all the code you need to have this basic sort of terrain generation. So I hope you enjoyed watching. And if you did, I'd appreciate any feedback in the comments or just anything like that. And I'll see you next time. Goodbye.